Imagine that. Some red thorns and poor landscapes on Mars transformed into a green landscape. It became a free flow. Carve a canyon, the planet that forms lakes and oceans. Can we rely exclusively on pour water into the ground to actualize this desire? Before rushing to deny, why don't you join me in researching this camera in depth? What if we could magically transferring all of Earth's water to Mars? This will be an excellent opportunity in engineering and logistics. Crazy challenge. The first challenge we encounter. Millions of cubic meters of water removed from the Earth. This requires a huge container. Next, we need to discover a way. Launch these massive, water-soluble vehicles into orbit. That is completely correct. The ultimate test of rocket technology and massive quantities of fuel. We might need to build a fleet of spaceships constructed specifically for this mission. Imagine that. A pair of giants loaded with properly collected water sources. A spaceship is launched from Earth. How amazing it will be to go into space. Another option that could be more practical is, as it goes by, launch a vast number of smaller missions. Every mission demands less water. To carry sufficient water to Mars. Suppose we conquer all of these problems and successfully reach Mars. Here's what we'll do next. Distribute this water on the surface of Mars. We can use underground pipelines, network, or customized drones send water to different locations. As you can see, this demands significant planning and resources. This crazy project involves scientists from all across the world, engineer and aerospace institutional tight cooperation and coordination. But even if we address all the problems, pour Earth's water onto Mars, the outcome can be frustrating. Mars is dry desert planet. Its atmosphere is just approximately 1% thicker than Earth's. This signifies that almost any moisture evaporates swiftly. The temperature on the surface of Mars is well below freezing. The thin atmosphere will just exacerbate evaporation or freezing of water. The magnetic field on Mars is quite feeble, unable to resist the sun's peak. These streams of charged particles are easily transported away. Any wetness on the surface of Mars? The intensity of solar radiation on Mars is likewise significantly higher than that on Earth. Increases the difficulty of maintaining liquid water. And we also need to cleanse the water to eliminate all bacteria. Maintain their appetite for drinking. Despite this, if we remain positive, it is still conceivable to solve these challenges in the long term. Essentially, we need to discover a means to keep the water liquid for a long time. Make sure it doesn't freeze or evaporate. One option is to utilize insulation, such as foam or reflective materials. Wrap the water container. Helps keep water from freezing. In addition, we can utilize heaters and other equipment. Maintain the water temperature above freezing, although this will use a large amount of energy, and that's a tall order. In addition, we could also explore developing subsurface reservoirs. Dig huge holes and cover with transparent materials. Using sunlight to regulate the water temperature, simultaneous insulation, add a small amount of salt to the water, or other dissolved minerals, can lower the freezing point of water. Although this is required for the construction of the lake, waiting for enormous bodies of water is not the most effective technique. And finally, create greenhouses or other structures that can absorb heat. Create a construction that is closer to the Earth's surroundings. Might be the best option. After all, greenhouses may not just help us grow plants on Mars. Plant several plants. It can also support other types of life. Assume we have found a way. Storing water on Mars, and keeps it lukewarm in its liquid condition. What effect will this have on Mars? Actually, this will be a wonderful transition. If we could pump vast amounts of water over Mars, could greatly change this cold red climate of a colorful desert planet. Our first, to generate the so-called greenhouse effect gases in a planet's atmosphere trap heat, causing global temperatures to rise. Although this is a concern for the Earth, but for Mars, its temperature ranges between -60 and 120 degrees Celsius. The introduction of the greenhouse effect will be quite significant. This may make the atmosphere thicker, and may cause the polar ice caps to melt. Imagine that. Mars is rapidly transitioning into a new Earth 2.0. Not only does the atmosphere alter, weather patterns can form. For example, there is cloud river rain. This is beneficial for watering of plants. This would be a major step forward. However, all of these concepts are still at the hypothetical stage. We can't be completely sure. Introducing water on the surface of Mars, what impact will it have on the climate? Although there might be a greenhouse effect, but the amount of water we require, much more than we can transport. Even if we overcome every challenge successfully made Mars warmer and wetter, it's unclear whether life can be born there, although water is necessary for life. However, not all life needs Mars. Soil is unsuitable for supporting life, mostly made of dust that is harmful to plants. Sand and other minerals. We could, theoretically, attempt to terraform Mars. However, the task will be quite complicated, a lengthy and costly process. And consider the cost of moving vast amounts of water from the Earth. This type of conduct may affect our own planet, have undesirable effects, especially in areas where water is already scarce. From every perspective, this was an impractical strategy. He requires too much resources and finances. It could also be prohibitively expensive. This explains why scientists and space agencies it was not accepted as a viable agenda. To consider instead, focus on more realistic and attainable goals, such as examining the geology of Mars, atmosphere, and the possibility of exploring previous or present existence. Imagine that you're in another universe. The sky blazes with scarlet brilliance. There's a limitless extension, spreading reddish-brown plains and towering volcanoes. This is our neighbor Mars. He is a planet in our solar system. For millennia, has always stimulated the human imagination. Map the night sky from ancient astronomers to the current Mars rover. Crossing the rough landscape on Mars, humans continue to discover this extraterrestrial planet. The mystery of the world Mars has always been an intriguing mystery. Its intriguing features have inspired many debates. It has also inspired many science fiction stories. However, if you know his real face, you will find the true story of Mars more intriguing than any novel. NASA's Mars Atmospheric and Volatile Models Chemical Detector Maven spacecraft humans can explore farther into Mars, to locations that we have never seen with our naked eyes since 2014. Plum Kiss had been orbiting Mars, using his superior sensors to probe far into the Martian atmosphere, capture photos outside the visual spectrum. Many long-hidden secrets were revealed. A journey to explore Mars. It didn't start with cutting-edge aerospace technology and advanced imaging technology. It dates back centuries. At that moment, ancient astronomers have fascinating eyes and simple telescopes, mapping the course of Mars in the night sky. Notice his characteristic red glow. However, it wasn't until the 17th century invention of the telescope humans saw the red planet for the first time. Early observers witnessed the polar ice caps and confusing black areas for oceans and continents. In the 19th century, human comprehension of Mars, but owing to misreading the surface of Mars, the river was not understood. Spark about fire, the wild hypotheses of star civilization, the beginning of the space age in the 20th century, make Mars a primary target for exploration. In 1965, NASA sailors' flight for the spacecraft accomplished the first successful voyage to Mars, sending back the first close-up images of Mars since. Many orbiters are imaged by national space organizations. Lander and rover together, they took on the mission of exploring Mars. One of the most significant approaches to get a better grasp of Mars, it is a significant advancement in Xinjiang technology. From grainy black and white images from the Mariner mission with today's high-resolution panoramic color red and white, or even UV pictures, we have gone a long way. Especially the ultraviolet Prime Minister opens a fresh window on Mars for us. They enable us to perceive things we cannot see. The Martian atmosphere complex interaction with solar radiation. This is NASA's Mars Atmospheric and Volatile Models Chemical Detector, the key of the unsteady mission. It carries the UV imaging shooter. IUVS revolutionized our understanding of Mars. In the incentive race to discover Mars, Melvin, it stands out for its innovative research methods, unraveled numerous riddles of the red planet. NASA scientists launched MAVEN in 2013. Its main purpose is to research the upper atmosphere of Mars. Unlike the rovers that examined the surface of Mars, Melvin, since 2014, It has been orbiting Mars, focusing on observing the Martian atmosphere and in-depth examination of its link to the solar-class Sun-Wind interaction. Understanding Mars, how over time, lost the majority of the mood. From the warm, the moist world evolved into the cold and barren Earth we know today, is a crucial mission for MAVEN. The MAVEN mission revolves around remarkable instruments. UV Prime Phase Spectrometer, IUVS. This equipment not only captures photographs of Mars, it can also collect UV light. Let us have a glance. Details that are hidden to the naked eye. Ultraviolet light is especially important for researching the Martian environment. When the sun's UV rays enter the Martian atmosphere, will interact with the gases within it, cause them to shine. The wavelength range measured by IUVS is 110 to 340 nanometers, far beyond the visual spectrum. This observation is similar, opens up a completely new dimension, allow us to obtain previously inaccessible information areas. But how do we? Converting this invisible light into what we can understand. The solution is in something called a color picture. Generative color technology. During the imaging procedure at IUVS, certain wavelengths of ultraviolet energy are linked to the visible colors from the spectrum. Therefore, they are in person. It becomes visible in the color display. Using IUVS for color images, various wavelengths of UV energy are given red. The three main colors are green and blue. The shortest wavelength is around 110 nanometers. Blue represents medium wavelengths, which are around 180 nanometers. Green indicates the longest wavelength, which is up to 340 nanometers. Marked with red by allocating colors to certain wavelengths, we can create models that show the intricacy of the Martian atmosphere. Detailed picture. But it's not all about the colors. The brightness of each color correlates to the intensity of UV radiation. Areas with increased brightness imply more radiation intensity, suggesting a gas or element identified by IUVS. Increased concentration of pigments by mixing these different levels of color and brightness. IUVS made a painting. Comprehensive UV spectroscopy of the Martian atmosphere. It's like painting. However, we are using various wavelengths and powerful the degree of light rather than watercolors or oil paints. These photographs are not just stunning. It was fantastic. They illustrate diverse conditions in the Martian atmosphere. Distribution of gas, effects of solar radiation, the impact of dust storms on atmospheric loss. Through the prism of IUVS, we see Mars in a whole new light. From answering Mars, what happened with the atmosphere, the age-old question goes further. What the no-text task has to offer us is incredible. Size ultraviolet view of Mars. They are in orbit around Mars, blazing the sun. Taken at several locales. Discovered Mars. This is red seasonal shifts and distinct perspectives on colorful planets. Images captured every night imply Mars atmosphere changes throughout the year. Significant changes. They showed stuff like CO2 and ozone. Distribution of gas, how to change with the seasons, like the face of the plants on Earth. The color varies with the seasons. The first photograph was captured in July 2022. It is the summer of Mars recovering. This is also the moment when Mars comes closest to the Sun. The planet's rotational axis is tilted. Mars' southern hemisphere enters summer. The seasonal fluctuations are identical to those on Earth. In this photograph, we see the Algar Basin, one of Mars' deepest craters, covered in pastel pink atmospheric thin. The deep gorges of the Tambourine had blackened. Shrouded with brown clouds, the Antarctic ice sheet is shown as the white depth below. Summers are relatively warm and shrinking. Another image was captured in January 2023. After Mars reaches its furthest orbit from the Sun, the northern hemisphere experiences substantial seasonal fluctuations. A bunch of white clouds appear. The deep canyon of Mariner Valley is located in the lower left corner of the photograph, presented in tan. Ozone during the northern hemisphere's winter displayed as pink in the photograph, scattered over several craters generated by the orbiter. These images, they gave us information concerning Martian atmosphere and solar radiation. Relevant information concerning encounters. The various hues depict the atmosphere. Various elements and compounds, their distribution supports the climate of Mars and weather conditions. For instance, in the image, the purple area reflects ozone levels in the atmosphere. The white and blue sections depict active clouds and haze. The sky on the surface of Mars appears brown or green. It relies on how the image's contrast is maximized. The photographs also show the sun. The effect of radiation on the Martian atmosphere are brilliant spot areas of the atmosphere that react significantly to solar radiation. This reflects the rate of atmospheric loss. MAVEN's photos give us with observations about Mars a new perspective on the sandstorm. These storms can envelop whole planets, a significant impact on the atmosphere. The image depicts the dust particles rise to the upper atmosphere, adapt its constituent heterogeneity. For these breathtaking ultraviolet photos of Mars offers a plethora of knowledge. We look forward to the future exploration of Mars. MAVEN Task has substantially advanced our understanding of the Martian atmosphere, understanding the interaction with solar radiation. But that's only the beginning. Data and photos from MAVEN will continue to be collected, analysis and interpretation, paving the way for future scientific breakthroughs. Take Venus. Even analyzing data from 30 years ago can still be located in unexpected revelation. One of the definitions of the unwritten duty in its future. Potential applications for Mars expeditions. Developing a better grasp of the dramatic variations in the Martian atmosphere, we can better plan for the robots of tomorrow and manned missions to Mars. For example, the PALM. The weather and atmospheric conditions of Mars helps design adapt spacecraft and equipment in the hostile environment on Mars, and can help choosing the optimal landing place for future missions. Meanwhile, scientists examine Mars. Research discoveries about the vanishing of the atmosphere also provides us with this world habitability clues from the past. This will help us find signs of life once existed on Mars. This is an important goal for future Mars missions. Looking into the future, we can imagine humans. The instant you step on Mars, understanding of stability maintenance and other associated responsibilities. It will contribute to this groundbreaking project. Provide vital preparedness. In fact, as we continue to investigate Mars, we need to discuss things in advance, such as what exists on this planet, a plan to establish human existence. We can expect more advanced city wall technology development. He'll share additional information about Mars, from subsurface structures to the smallest dust particles. The route to explore Mars is long and difficult, but every mission and discovery bring us closer. Uncover the wonders of the Crimson Planet. Maybe someday, we can not just observe Mars in ultraviolet light. Stand on the surface of Mars, look at this fascinating star with both eyes. Humans have thought about colonization for many years. The potential of another planet. Once we can travel through space, we will depart from a planet, move to the next world, inhabit, and change these realms on new planets. Imagine hundreds, thousands of rows similar to those seen on Earth. The stars were colonized by humanity. Life is about our journey across space. Trajectory bloom eventually. The Milky Way will be full of beautiful Earth. However, to accomplish this goal, it should be like any significant project. Start small. Can you envision in the next 10 years? Humans may begin to reproduce. Is it our solar system? Today, we will journey to a nearby planet. Let us see whether there is life on Mars. At first view, the red planet appears to be distant from the Earth, only approximately 68.8 million kilometers, but absolutely uninhabitable. There are no rivers on Mars. No fresh air. No food. The surface gravity is 1/3 less than that of the Earth. Long-term negative impact on human health. The vibe there previously contained several gases that were hazardous to humans. Therefore, oxygen supply is necessary. Due to low pressure and constant solar radiation without a spacesuit, humans cannot operate on the surface of Mars. So the first humans to land on Mars and succeeding colonists. How to thrive in such an environment. So, let's start with this. Let's tackle the oxygen problem in tough environments. April 2021, scientists are already heading in this path. Significant progress was made. Mars rover standing Hiroshi, successful application of a method termed MOX system tools electrolysis by solid oxide extracting oxygen from the atmosphere. In the foreseeable future, this technology will be similar to the trees on Earth. Function because technology already exists. You just need to scale it up. To address the requirements of future colonies, as for the ships that transported the initial inhabitants expected, it will be equipped with high-efficiency equipment, like those on the International Space Station. The water circulation system, the astronaut looked for probable water sources on Mars. Provide a certain level of freedom. The solar system was in its early phases of development. The presence of water on Mars is highly likely. Previous missions had discovered water is a mineral on Mars, and portion of the soil's composition, and reliably confirmed. The amount of water on Mars is primarily concentrated in the tens of permanents after a few hundred meters. Restricted region of permafrost. The majority of the ice on the surface lies below the surface, due to the present climate conditions unable to exist steadily. Once exposed to the surface, it sublimates quickly. Only the poles are frigid enough. This keeps the ice steady year-round. Form the so-called organs. The ice volume is calculated at 5 million cubic kilometers. Fresh water on Earth, the entire volume of lakes and rivers, is only 100,000 cubic kilometers. If they freeze, it might be on Mars. The surface is produced in a layer of water 35 m deep. In 2018, the Mars rover found 1.5 kilometers beneath the South Pole ice sheet of Mars. The diameter is roughly 16 kilometers of Ice Gorge Lake. The first permanent body of water on Mars has been installed. In 2021, the European Space Agency's space probe can detect locations tens of meters deep. On Mars, large volumes of water sediment have been detected in the Grand Canyon. This sediment is fire. The world's most accessible water source makes Wallace Sailor. The network of canyons became our home on the Red Planet. The first option for starting a colony exploration site, spaceship supplies, will not last forever. Therefore, the colony must establish self-sufficiency. Growing edible crops. Scientists are optimistic about the technique. Because of the composition of the top layer of the Martian soil, it includes numerous nutrients that plants require to grow, like egg carapace and phosphorus. Once we can stabilize the air supply, water, and food, you can use existing resources. Build one for construction. The optimal platform for the colony Martian soil can serve as a building material. Build to safeguard the settlers. Protection against solar radiation and dust storms invading the shelter. The most convenient technology is to employ a huge 3D printer for construction. This technology has been utilized on Earth and on fire. In a severe climate like Star, it can also establish its value. Due to the limiting conditions of Mars for the first colony, people's land generates benefits, all the needs and equipment needed for living situations. They were initially transported by planetary spacecraft. But how can we travel to Mars? Currently, there are several projects developing confirmed spacecraft. The building of spaces take the lead in terms of progression. December 2023, new construction will undergo its first orbital test flight. The launch vehicle will be a supercentral rocket. One of the distinguishing characteristics of this rocket is that both it and the spaceship are reusable and can refuel in Earth orbit. Once the spaceship reaches its target, Mars can renew its natural resources, water and CO2. This is quite good for us. These factors significantly lower production and transportation expenses. The colony also required power to keep things operating. Even removing air, basic necessities such as water and food also require electricity. Fortunately, Mars has a large reserve of knives. Knives are also called as heavy hydrogen, suitable for heat and reactions. 0.034 liters of heavy hydrogen liquid fuel can be generated. That's 20 tons of enzyme energy. We need a fusion reactor. Recently, American scientists were appointed. A breakthrough has occurred in the world of energy. Success with any reaction. I gained useful energy. However, the problem still exists. Can this colony become self-sufficient? One day, Mars will no longer require Earth's help. Exactly like America before the Revolutionary War. Gradually become self-sufficient. Self-sufficient. So, what would life on Mars be like? Could we be on fire? Grow your own food in the star's greenhouse. Wild creatures. Birds howl, fish, rivers, and oceans coexist. Terraforming became a need. Terraforming, essentially the process of building another Earth. Universal consensus city terraforming is a prerequisite for global colonization. and terraforming necessitates global colonization. Thus, these ideas are inextricably linked. We can implement the terraforming process, divide it into multiple stages, enabling life on Mars, gradually reaching the state of the Earth, as the first colonists to reach Mars. At this stage, one can only wear enough oxygen, gas supply for spacesuit life. We will have unusually low temperatures. The atmosphere contains hazardous gases and extremely low air pressure. The surface of Mars pressure is less than 1% of the Earth's atmospheric pressure. Additionally, cosmic rays can penetrate almost the entire surface of Mars because of Mars. There is minimal magnetic field to shield us from radiation damage. For reference, the quantity of radiation one receives on Mars 40 times the size of Earth. Next stage, we shall attempt to establish conditions, allowing individuals to use simply oxygen masks. Leave the shelter without a spacesuit. To do this, we should be aware about radiation issues such as temperature and air density, reducing the reflectance of the Martian surface, improved utilization of sunlight to absorb heat, and warm the atmosphere of Mars. This can be done from the Martian moon Phobos, scattered across Deimos dark dust to obtain 2 satellites. It is one of the fainter objects in the solar system. Another the option is to introduce dark extremophiles, life forms such as the first algae and bacteria, so the surface absorbs more sunlight. Increase the atmospheric temperature. If algae or other plants take root, it also adds a small amount of oxygen to the environment, but it isn't enough to allow humans to breathe without assistance. April 2012, scientists in the Mars Simulation Laboratory, a 34-day simulation experiment was performed under the conditions. Results show that the first survives. In terms of flexibility, photosynthetic activity's significant outcomes were achieved. Despite this, Mars is already the second planet in our solar system, absorbs more than 70% of the sunlight that enters the house. Thus, there is essentially no additional darkening space. Another issue with this approach is the identification of Mars. Periodic sandstorm. These dust storms will spread over the Earth for weeks. Once the dust reaches the ground, it not only increases the reflectance, it also blocks sunlight from reaching the surface. It sticks to anything it touches. Effective occlusion prior, anything deposited on the surface, make it impossible for sunlight to reach. Terraforming on Mars will bring about 3 significant connected developments: formation of the magnetosphere, the creation of the atmosphere, and the rise in temperature. The atmosphere on Mars is relatively thin, extremely low surface pressure. Its atmosphere is primarily made of carbon dioxide. When Mars begins to warm up, carbon dioxide can assist keep heat near the surface. In addition, when the freezing of Earth's poles, as more CO2 in the reservoirs warms, will release more CO2 into the atmosphere. Enhance the greenhouse effect. Improving the Martian atmosphere. Increase. Another technique to strengthen the greenhouse effect is to inject ammonia, methane, and other hydrocarbons to detect huge concentrations of ammonia and hydrocarbon deposits frozen in a tiny celestial body, such as Titan, which orbits the solar system. These may change or contain a significant amount of the above orbit of a tiny celestial body of substance, make them collide with Mars, thus releasing them into the Martian atmosphere. But even if we can find a way, the law prohibits certain chemicals unleashed into space. Methane can only be found in the Martian atmosphere, exists for a limited period, then it'll be destroyed. It is speculated that the gas will ultimately pass Martian environment with glass, exhausted from the same method. Most of the original Mars. This is how the environment is glassed. However, these processes are believed to have taken hundreds of millions of years. Over time, we have generated a large number of people on this planet. Well-known chemicals can aid us. In particular, several powerful greenhouse gases. Take hexafluoroma, for example. Alflutin or perfluorocarbon. These gases are more effective greenhouse gases than carbon dioxide. Thousands of times stronger. It is anticipated that approximately 0.3 V is necessary. 8 of these gases are pumped into the Martian atmosphere to melt CO2, laden Antarctic glaciers. That is 1972. The amount of carbon dioxide created on Earth before 1990 to approximately 3 times the mass of the gas at the time. International treaties outlawed the production. Maintain temperature. Continuous synthesis of these chemicals is necessary because they will be destroyed by the action of the light. According to the calculations, introducing 170 tons of the best greenhouse ingredients per year, enough to sustain the greenhouse effect. Despite all these efforts, it's still difficult to sustain the greenhouse effect due to the absence of a protective global magnetic field. It's difficult to shield the atmosphere against solar wind. One of the keys to altering Mars is protecting the present. Current and future atmospheres are not distributed throughout space. Some scientists propose generating an artificial magnetic field. National Rihi of Japan scientists from the Institute of Science say the global magnetosphere may help fix this problem. This can be accomplished utilizing modern technologies. By developing a cooling tail superconducting ring system, each ring contains a sufficient number of DC points, can generate an efficient magnetic field system. This not only protects Mars, protected against solar wind erosion, it can also be used to transmit energy throughout the Earth and storage system to limit its economic impact. Planetary Science Micro Review 2050 by the end of February 2017. At the seminar, NASA scientist Jim Green came up with the idea of placing Tsuo-Gizi, that is establishing a magnetic field between Mars and the Sun, to defend against the effects of high-energy solar particles. Imagine that. Located on Mars, a Lagrange point has a radius of around 320 kilometers. LED placement, a gigantic magnet creates an artificial magnetosphere. This magnetic field should be equivalent with that of the Earth. Approximately 1 to 2 Tesla once made and placed on the track, the shield could allow Mars to partially restore its atmosphere and prevent memories from disappearing. Another entry into the invisible structure. It is an equivalent suit. Virginia huge mirror, made of a thin metal film. Such a mirror, it can be positioned in orbit around Mars. To improve the overall exposure it receives, this drastically raises the surface temperature of Mars. A mirror having a radius of 124 kilometers, we can benefit from the effects of solar sails, positioned at 2 levels relative to Mars. Nearby stationary track, to discharge CO2 deposits from the ice sheet and contribute to general warming via the greenhouse effect. The present main obstacles is from the soil. The process of delivering a huge mirror to Mars, but it will finally be overcome. Follow these steps, we will eventually reach the last stage of terraforming. This procedure may take hundreds of years, but at the end increase overall oxygen levels by introducing plants. Create new biomes on Mars. People will be able to move freely and breathe thoroughly. There is absolutely no need for any additional support equipment. Once Mars capacity exceeds consumer demand, here we go. Waiting on our guys to collect rare goods from Mars. Metals like platinum and silver. The following steps will be Mars becomes a resource-rich planet. Lay the foundation. Transporting resources from Mars to Earth, it will also become significantly easier than it is presently. Even more hopeful. The asteroid belt is extremely close to Mars. Consider the asteroid belt, for example. Details on the discovered asteroid satellite. It measures 1.3 kilometers in diameter. Distance letter, there is more iron than anybody have ever used. The asteroids can be found in mining fairly close to Mars and transfer it back to Mars for a reduced cost. For example, Pastora and KSC has plans to mine asteroids, build a shallow base on Mars. This makes these plans more achievable. We may notice a line, similar to the 18th century. British New Indies, the presence of a triangle trading route with North America. This new economy possesses enormous promise. There are enormous hurdles at every level, but human exploration, the spirit of conquest, and conquest makes everything possible. It is simply a matter of time. After successfully populating Mars, what awaits us? Are we going to start mining on a large scale? Asteroids will create a new economic structure. Will humanity continue to conquer the next planet? Or will we build a huge space station to examine neighboring galaxies? The answer is still unknown. However, we can be certain of making consistent progress every step of the way. We will eventually reach these ambitious aims. Mining robots are active on Mars. They drill, blasting and removing soil and rocks, making space for new settlements beneath the surface of Mars. We will explore, is it truly possible to be in this area? An entire civilization was established beneath the new sky. Now, the craters on Mars are being dug more than ever before. Deep anytime. Martian dust is transformed into structurally sound bricks. It's like ants making a nest. Imagine that. How big is the underground city? Where did he get his building materials? Again, how to create layers of protection on top of craters to protect the security and well-being of city dwellers. But why select an underground city? Because subterranean provides some kind of protection, can endure the increasing surface radiation storm. Every time the Earth is closest to Mars, underground city Wallace A2 Arcadia is prepared for the next wave. Huge waves of migration. There will be 20,000 robots and 10,000 people. Passenger landing the red planet, working amid dust storms and extreme conditions, extreme temperature changes. Makes mining robots vital for cities. Lay a firm foundation. This enormous undertaking arose from the crater. To begin, establish workstations at the top and bottom. These workstations by cable car and conveyor belt send materials and equipment. As the project advances, this is a cable car system, will be replaced by more advanced maglev trains. For more efficient transportation of people, the excavation of the city infrastructure developments are estimated to need 3 years to complete. Autonomous robots operating around the clock. Martian soil and plant-based adhesives transformed into something called Expose Mars concrete through the nozzle and injection system. This concrete was printed layer by layer, building the basis of the city's simultaneous metal beam. Zhuang had ventured deeply into the crater. Stabilize city walls to prevent collapse and landslides, especially during a Martian earthquake. Small, nimble drones fly around, check the integrity of the foundation, and help weave reinforcement material. An urban shell was formed. Toward the end of the foundation phase, the excavating robot did not stop. They started excavating the flank of the city and make more space for life on Mars. The volcano was deliberately chosen as the location for the metropolis because of its proximity to plentiful resources, include enormous underground ice, water, and mineral resources. Like settlers on Earth, would prefer to build colonies near rivers. Lack of active plate tectonics on Mars means surface features such as cloud craters. It is not like oxygen on Earth, easily eroded. The city covers an area of approximately 64 kilometers, approximately 200 meters deep, provides a diameter of about 9,910 meters of living space. Martian dirt is particularly thermally appealing, so that it can absorb throughout the day and slowly release heat. As a result, the temperature beneath the surface is more steady than that above it. There is no such thing as 20 degrees Celsius extremes. Surface habitats during frigid nights. It takes a lot of energy to heat it up, even though the foundation phase is completed. On the crater rim, there's still some excavation going on. In order to construct some unique elements away from the residential area special facilities, the next phase for cities is to create a structural framework. It is going to take 6 years. The city will be built 8 floors high. In this Mars settlement in the far north, multi-level open spaces and courtyard distribution, there is a biological dome with a tiny lake. It can house more than 52,000 people, residents and more, 120,000 robot laborers. This society operates at a high level. Civilization with integrated robots. The robot-to-human ratio has hit 2 to 1. Robots in construction, mining, maintenance, healthcare, and housework and other professions play an important part. The amazing thing is the robots, it requires less than 1 square meter of storage space. And human inhabitants, it needs 200 square meters of area to survive. This is the city which was built. Why was it built underground? Lethal radiation at the surface, toxic dust storms, and several meteorite impacts. The living conditions on the Earth are exceedingly tough. The natural environment of Mars lacks a protective magnetic field, thin atmosphere. It is nearly impossible to counteract cosmic rays and solar energy. This radiation can permeate biological tissues, causing significant harm to DNA and biological components. The consequences are similar to intense sunburn. However, the damage occurs at the cellular level. Destroy life from the inside out. Additionally, the universe emits high-energy radiation, include galactic cosmic rays coming from all directions, increasing the risk of life on the surface of Mars. To endure the harsh environmental conditions, the subterranean habitat utilizes thick Martian dirt, 3D printed shells, and other radiation protection measures, for instance, constructing water tanks and walls around dwelling areas. However, even the soil on Mars, it also contains perchlorate, which is harmful to people. It must be washed through bioreactors with water to remove hazardous pollutants. Additionally, the reduced gravity environment on Mars poses a threat to humanity. Bone density impacts, but modern bioengineering nuclear gene therapy technology provides promise for solving this challenge. In this closed crater city, the climate is artificially controlled. The environment was made to be breathable. One of the key issues in developing cities is in the room at the crater. The roof provides additional radiation protection for occupants. At the same time, a little aperture was left in the center of the roof. It is covered in radiation-filtering composite glass. The roof was also built to withstand meteorite impacts, protect urban safety during a protracted dust storm, and during the sun-like activity. A retractable protective cover can be completely close the aperture, ensuring the security of the city. The roof structure consists of a structure that can endure Mars. Frame support for lower gravity. The city is meant to be 8 floors tall, filled by swarms of welding robots. These robots are working around the crater. The city's creation required significant effort. This city is located below Earth. It will be a place filled with brightness, a clean and comfortable living environment. It resembles a real-life hobbit settlement. The space will be adorned with polished wood furnishings, lab-grown wood fiber constructed boxboard, and plywood manufactured from plant bio-glue. The flooring is carpeted, decorated with colonial-style furniture. Through the aperture in the roof, residents can utilize a telescope in the city center. Observatories monitor the thin atmosphere of Mars to highlight the breathtaking beauty of the night sky. The city lights dim temporarily every week, ensure that residents can admire the natural splendor of the late-night sky. In the biota of the Martian colony, a little man named Luo the lake becomes a sanctuary of calm. The water flows slowly, demonstrates a low-gravity environment. Water bodies exhibit unique behavior. The plants inside the city walls grew swiftly, towering over the occupants. Not just beautify the environment, it also supplies meals for the locals. Additionally, an iconic office building, the Institute for Terraforming, is going to open. It represents that this metropolis is more than just humans. A great example of engineering. It is also a masterpiece of Pratt's artistic and technological integration. Terraforming is turn a certain spot into art and technology. In an Earth-like setting, it isn't about transforming the entire world, but somewhere particular. This respectable institution working to green additional parts of Mars. Aim for a horse. Despite dwelling beneath the surface, it might be excellent for the mental core. Seems like a challenge, but these underground houses, it maintains a controlled atmosphere, minimizing the impact of extreme circumstances on the Martian surface, and create a warm environment, a homely atmosphere. Due to the thin atmosphere of Mars, unable to breathe directly, cities must be pressurized. It resembles a sealed airplane, molded by actively pumping air. The atmospheric conditions of the Earth, this process, it is required to ensure the integrity of the building structure. Solidity and sealing prevent gas leaks, using long-lasting materials like metal rigid composites. All of them are produced on Mars. The evolution of colonial technology, it is possible to construct underground cities. The colony is prepared to use Mars concrete construction facade, and using Martian rocks. The abundant iron oxide in stone produces steel. Iron capacity metal processing facilities are situated distant from residential areas, operated solely by robots, manufactured for building steel, tools, and machinery, titanium, and other metallic materials. Additionally, Martian silica resource, it is used to manufacture fiberglass and other building materials. Building materials, including aerogels and polymers. All of these are made locally on Mars. Next, significant infrastructure buildings in the city. It will take approximately 3 years. Includes water and air treatment distribution plants, waste recycling system, vertical farming towers, commuter networks, etc. Make sure that residents to become self-sufficient in this underground city. Self-contained life at the same time. Construction of emergency shelters and reinforced places. Residents in severe weather or providing shelter in other emergencies. The energy heart of cities. It is a series of fusion reactors. Used from hydrogen derived from Martian ice water for fuel, ensure the stability of energy supply. The city was called Wallace Arcadia, inspired by the canyon system of Mars. A lovely retreat that represents the untouched wilderness. Mythical Arcadia. Upon completion of the construction, this self-sufficient civilizations will achieve new advances. Despite remaining dependent on the Earth's advanced electronic equipment, robots and AI Mars colonies have exceeded Earth in several aspects, especially in medical development, genetic and biological engineering. Significant progress was made, including using 3D bioprinting to create tissues. The cornea of the eye, prosthetics and experiments in organ printing utilize the natural resources of Mars, include carbon taken from the atmosphere, oxygen, hydrogen, etc. Colonies were capable of producing their own medications, food, preservative, building supplies, and explosives. Furthermore, tortoise tablets recovered from Martian rocks, used in the manufacture of solar panels. Energy supply for the colonies made an essential contribution. The soil of Mars was treated at tremendous temperatures. It can also be utilized to produce other ceramic materials. The colonies were mined for electronics, precious metal deposits for scientific instruments. Rugine and Bo. These structures have evolved into the darkness. The fourth phase of bringing energy to the city during the day, when the artificial lighting system starts up. Residents on the ground. You can see the light coming from the roof. The interior lighting technology simulates natural sunlight. It increases plant growth. Also promotes human circadian cycles. Controlling the environment with artificial intelligence. He is the brain of the city. Working with robots stationed there. Maintain the life knowledge system. Monitoring oxygen, levels of CO2, and contaminants, and according to maintenance. Optimal human health requires the management of conditions. Robot convoys are deployed throughout the city. The metropolis appears to develop underneath the floor. Wall bacterial communities and sealing cultures. The city is now closed. The ring ecosystem, by circulating air and water. Get enough pressure. Start breathing. Elevators and spiral staircases provide access to the entire city. Escalator connection for residents. It offers easy access to every level of the city, and others who must go huge distances. You can enjoy magnetic levitation. Small railways allow for smoother travels. These railroads take advantage of Mars's lower gravity, moving people and products throughout cities. When people need to go to the surface of Mars, they can take high-capacity trips that link with the Earth. Freight and passenger elevator with an inclined floor. The railway provides a picturesque path. The pressurized compartment docks with the airlock station on the surface. Become one of the city's leading tourist attractions. On their way to the surface of the Martian settlement, passengers can board the buses. Leave a jetpack to travel. This is a significantly more evolved civilization. He expanded his business by trading the planet. Driven by continuous expansion, colonies became scientific research, material science, food crops, and genetic engineering of human biology, and a trading center for biotechnology. Its products are transported back to Earth, sell in multiple ways. There is a vault farther inside the city. Saves digital data delivered from Earth, seeds and human DNA, serving as a sort of vault for an extinct world deep below the city. There is a cloning laboratory for Earth animals. Specializes in animal cloning operations on the surface of Mars. Companies on Earth pay those who own locally, a corporation with professional knowledge, to construct research outposts and tourist amenities. These initiatives are starting to scale up, not just on the 2 moons of Mars. Morse and Fire building. It also has a series of new landing locations, in addition to housing and rocket building facilities in the city. These facilities will be rented to corporations in the asteroid belt and Jupiter. 95 satellites. Earth Corporation on a mission. Thanks for watching. If you enjoyed this video, be sure to like, comment, and subscribe to Galactic Discovery's Quest. Don't forget to turn on the notification bell to get our latest videos as soon as they're out. See you next video.